Today we are looking at Leetcode number 2. It's called Add Two Numbers. So this is a tricky problem in the sense that you really have to look at the prompt. You could go down one path and end up finding out that that was the wrong way to go if you don't really kind of clearly read what this problem is asking and what the constraints are. Okay, so, and it's also a very frequently asked problem, and I believe, because of that constraint, noticing that constraint is one of the reasons companies like to ask this. You can see across the board, this problem is very frequently asked. Bloomberg, Microsoft, Amazon, Facebook, they like to ask this problem, so it's good to be familiar with it. Okay, so add two numbers. You're given two non-empty linked lists representing two non-negative integers. The digits are stored in reverse order, and each of their nodes contains a single digit. Add the two numbers and return the sum as a linked list. You may assume that the two numbers do not contain any leading zero, except the number 0 itself. So here we have 243 and 564, and our result is 708. And we can see here that if we reverse 342 and 465 and then add those two numbers together, we get our result, and just reverse that and put it turn it into a linked list, and that's our answer. And so let's take a look at how we would approach this. Let's take a look at the trap with this problem, and then let's take a look at the solution. One other thing I want to mention is in the constraints, you can see that the number of nodes in each linked list is in the range of 1 to 100. Okay, and that the list does not represent a number that does not have leading zeros. So this right here is really important to make a note of. Okay, so we have 243 and 564. So here we're going to have our two inputs here, which is going to be 243 and 564. And our result is going to be 708. Okay. Now, the brute force way, or the way to think about this, if you don't really look at what the question's asking, an initial way to probably think about this, which I'm sure many people do, is that, well, hey, why don't I just take this linked list here, 243, 564, I'll convert it into an array, and then push all these elements into an array and reverse it. So I'll end up with a number 342, and then I'll end up with a number 465. I'll just do a simple addition operation, get the number 807. I'll split this, I'll turn it into a string, 807, split it, and then just iterate over it, reverse it, and then just create a new linked list, and then I will have 708. Sorry, 708. And you can do it that way, but here's the problem. If your input is, let's say, not just 3 digits, okay, but what if you have an input where you have a very large amount of digits, right? So let's say you have an input of like 1, 0, 0, and then this goes on for like 56, okay? And then you want to add that to something like 7, 6, and then this goes on for 32, right? Your result, when you try to split these and join them and perform an addition operation, JavaScript won't be able to do it. The largest number I believe you can have in JavaScript is 2 to the 51, which I think is only around 14 digits. Okay, so you can't perform an addition operation on a number of this size that's going to 56 digits or 56 nodes or 32 nodes, right? You'll run into a problem when you try to do that addition operation. And so it won't work. It won't work for a large number. You have to use a linked list. You can't do it where you convert them into a number, you add them together, and then reconvert that into a linked list. Okay, so let's take a look at how to solve this with using a linked list. Okay, our inputs again were 2, 4, 3 and 5, 6, 4. So here we have 2, 4, 3 and 5, 6, 4, and then our result is 7, 0, 8. Okay, so now let's think about how we would add this just using using a carry. Okay, like if we were going to add this on pen and paper like you do in elementary school, right? You would have the number 3, 4, 2 and then 4, 6, 5, and then you would add this together. So what would you do? You would start from the right and you would add this 5 plus 2, okay, which would be 7. Okay, then you would do 6 plus 4, which would be 10. So you drop down the 0 and carry the 1, and now you would have 4 plus 3 plus 1, which would be 8. Okay, and so you can see here that this linked list right here is set up for us in that reverse order, right? So what we could do here is we could go ahead and remove this right here and grab this, make this a little bit bigger. Okay, what we could do here is we could go ahead and have a pointer L1, okay, a pointer at L2 at this list, and then a carry variable. We'll set that to 0. Okay, and now what we could do is we could add 5 plus 2. Okay, we could then we're going to get 7, so we'll go ahead and create a new linked list, our result list, and we can go ahead and set that initial node to 7. We could then increment L1, increment L2. Okay, carry will still be 0. We could now add 6 and 4, which is 10. Okay, and then what we can do is just get the right digit. Oh, and we can do that with a modulo operator, a mod operator, and just mod it by 10. If we mod any number by 10, we're going to get the rightmost digit. Okay, so we can do something like L1 plus L2 plus carry. In this case, it's 0. Mod it by 10, and that's going to give us the rightmost digit, and then we can add that to our list. Okay, which will be 0 in this case. And now we just update carry. Okay, and how do we update carry? Well, we want to get the leftmost digit, okay, or the left digit. And what we're going to do is we're just going to add these three together, L1 plus L2 plus carry, whatever was previously into carry, and we're going to floor it by 10. Okay, and that will equal carry, our new carry. So now we go into the next iteration. L1 moves to 3, L2 moves to 4, carry has been updated and carry equals 1. And then we do the same thing. We just add 3 plus 4, which is 7, plus carry, which is 8, mod it by 10, that's also going to be 8, and then we just add it to the list. Okay, and then we update carry, which is now what's going to happen is L3 and L4 is going to increment over. Oh, actually, you don't even have to. Yeah, you don't even have to do that. You can see that 3 plus 4 plus 1 is going to be 8. If you divide that by 10 and floor it, that's going to be 0, and we can break out of the loop. And then we just go ahead and return this right here. Okay, so I'm gonna go through this actually one more time, just to make sure it's really clear on how we're doing this. Okay, let me just clear some of this stuff out. Okay, so here we have L1, L2, and we're going to initialize carry to 0. And with result, what we want to do is we want to just initialize result to a dummy node and set it to -1. Okay, we'll set it to -1. That way we don't run into the bug of checking is result, we have to get that first value into result, that first node, and we don't want to have that check statement. So we can just create a dummy node and set it to result. And then we can also set the head of this to dummy, which is what we'll return. We'll return the next node on dummy. Okay, and so now what do we want to do? First thing we want to do is we want to get the rightmost digit, the next digit. Okay, so we can create a variable and we can call it next digit. Okay, and this is going to be the value of L1 plus L2 plus carry by mod 10. Okay, that's going to be the next digit that we want in our result. And in this case, it's going to be 7. So what we can do now is say result.next is going to equal a new node with next digit. Okay, then what we're going to want to do, result is pointing here. Now we have this 7. We want to increment our result pointer. Okay, so we can say result is going to equal result.next. Okay, and now what we want to do is we want to update our carry. Okay, so we want to say carry is going to equal floor of L1 plus L2 plus whatever previously was in carry, and we're going to go ahead and divide that by 10. Okay, and lastly what we want to do is just go ahead and update our L1 and L2, so we just increment L1 and L2. So L1 is going to equal L1 dot next, and L2 is going to equal L2 dot next. And with this, you want to we just want to make a slight modification to this, because if it is null, you cannot call dot next on a null value. So you just want to say if L1, then L1 dot next, else null. Same thing here for L2. We want to say if L2, then L2 dot next or null. Okay, and we want to encapsulate all of this in a while loop that is basically checking if L1 or L2 or carry is truthy, if there's any value in there. Okay, so now let's just kind of go over this iteration. We're at 7 right now. Okay, our carry is still 0. We're going to go in the next digit here, so we're going to have L1 plus L2 plus carry. So L1 moved over here, L2 moved over here. We have 6 plus 4, which is 10. 10 mod 10 is 0. So we're going to go ahead and add 0. We're going to move our result pointer, and we're going to update our carry, which is going to be L1 plus L2, which is 10, plus the previous carry, which is 0. We're going to floor that by 10, so that's going to be 1. Okay, that's going to get our leftmost digit. So now we have updated carry, and we're going to increment L1, we're going to increment L2, and we're going to just rinse and repeat. So now we're going to say 4 plus 3, which is 7, plus carry, which is 8, mod 10, which is also going to be 8. We're going to add this to our result list. We're going to move our result pointer here. And now we're going to update carry, which is going to be 8 floored by 10, or 8 divided by 10 floored, which is 0. Okay, and so now carry is going to be 0, L1 increments to null, L2 increments to null, and carry is 0, which also coerces to falsy. And so now we break out of the while loop, and what do we return? Well, our result pointer is on the last node here, so we can't return that. So that's why we keep this dummy variable here to have a reference to this -1, to this node that is right before the head. Okay, so what we want to return here is just dummy.next. Okay, and then that will return that right there, that node that's next to dummy, next of dummy. Okay, so that's the code. Let's just quickly take a look at time and space complexity here. So let's ask ourselves, how many times are we iterating over the list? Well, we're only iterating over each list once. Okay, so our worst case is going to be linear, O of n. Okay, and then what about how much space are we creating? Well, the result, we're going to have to create space for this result. We're going to have to create new space. We're not doing this in place. We're creating a new list for our result that is going to be relative to the size of the inputs. The bigger the inputs, the bigger the result, but it will be in a linear ratio. So our space complexity will also be O of n. Okay? So now let's jump over to the code. Okay, and what do we want to do? So first what we want to do is go ahead and create our carry variable and set it to 0. Okay, we want to create our result, and we will just create a new node, or new list node, and set it to -1. And then we want to just keep a reference to that as dummy, and we'll just set that to result. You can name this the other way around. You can say you can also switch it around. You can call the list node that we're iterating over creating as a dummy, and then the one that we're returning as the result. It doesn't matter. Okay, so now what we want to do is create our while loop, and we can say while L1 or L2 is not null, or carry is not 0, and you can just do this in one variable, and you can do it explicitly and write not null, but this will all coerce to falsy if carry is 0 or L1 or L2 is null. Okay, and so now what do we want to do? Well, we want to get the values of L1 and L2. So we can say let L1 val is going to equal, if L1 is true, then we want to go ahead and return the L1.val. Else we want to return 0. And the reason we want to do this is that if L1 is null and we try to call .val on it, it'll throw an error. So we just want to make sure that there is a node there. If there is a node there in L1, then we go ahead and return the value of it. If there's not a node there, then we just go ahead and return 0. Okay? We can do the same thing here for L2. Okay? And now what do we want to do? We want to get our next digit. Okay, so we can say let next digit, and we can go ahead and take the sum of L1 val plus L2 val plus carry, and then just mod it by 10. Okay. And now what do we want to do? We want to add this next digit to our result list. So we can say result.next is going to equal new list node next digit. Okay, so we've updated our result with that 7. And now we want to increment our result. So we can say result is going to equal result.next. All right. And now what do we have to do? Well, we have to update our carry. Okay, because now that we've taken care of our result. We've looked at what's on the rightmost digit. We have to now update our carry for the next round. So we can say carry is going to equal math.floor of L1 val plus L2 val plus whatever previously was in carry, and then divide that by 10. Okay? You want to just make sure you put L1, L2 plus carry in a separate parentheses, because if you don't, then there will be a bug there. It won't add and divide those integers in the proper order. Okay, so now that we've updated our carry, what do we want to do next? We want to just go ahead and increment our L1 and L2. So we can say L1 is going to equal, and the same thing, we want to do if L1 is true, then L1 dot next, else null. And L2 is going to equal, if L2 is, there's a node there, then L2 dot next, else we just set it to null. Okay. So now once we've done this, then we have a reference to dummy here that is at the head of the result, or at the very beginning of that result list, which is -1. So then all we want to do is just return dummy.next. Okay. Let's go ahead and run that. And yeah, we're good. Okay, so, and we went over space and time complexity. So this is a really tricky question. It's very frequently asked. I would not be shocked if people saw this in the wild all the time. So it's a good one to familiarize yourself with. The real trick to this question here is to not go down the route of turning this into an array, joining it, splitting it, and then adding the numbers, and then creating a new list from there. You can do it that way, but once your digit count goes above 15, 16, it won't work. You can't add two numbers where the digit count is 20 or 30. Like JavaScript cannot add integers that large. And so that's why you want to use a linked list. You want to do this in this method here where you're doing the carry, because then the list could be as long as you like. I mean, you can just go on, for a very, as much space as you have. So just a very important thing to remember when dealing with this problem. Okay, so that is Leetcode number 2, add two numbers. I hope you enjoyed it, and I will see you on the next one.